This is the fourth video in the series of videos belonging to three-dimensional characterization methods of beaches and dunes. The ultimate goal of this video is to get two digital terrain model from different dates from a zone with beaches and dunes to calculate their difference and to be able to analyze the changes. For this, we will use 2 points. Clouds acquired in the same area, but on two different dates, a point cloud from 2009 and a point cloud from 2015. For each of them, we aim to obtain a digital terrain model. To do this, we will need to follow the next steps. First, filter those points that belong to the ground which, as seen in video 3, will be done by the ground filter function. Then, that cloud of points will have to be interpolated to obtain a digital model of the field, which, using the fusion functions, will be exported in the own format, DTM. Then, by practicality and by standardizing the results, this asterisk DTM format will be converted to asterisk TIFF format. This will provide a digital terrain model in TIFF format for 2009 dates, a TIFF format DTM for 2015 dates, and will be able to calculate the differences to calculate those points that belong to the ground. We will use the ground filter function to easily access the function within QGIS. We can type ground filter. In the toolbox so that it is easily found. This tool, as we saw earlier, requires an input file. Requires the name of an output file with which we can drag the file here and edit its name. In this case, and format asterisk loss, a necessary parameter, is the kernel of analysis, the space that the algorithm will use to filter the points. In this case, we'll use a 5 meters kernel. In turn, as we saw in the previous video, the tools of Fusion allow to have switches which are added parameters which allow for modification the internal functioning of the algorithm. For this specific project, different values have been explored for different parameters. Specifically, we will use the value w equals 5. To do this, we will declare an added parameters w param. 5 space iterations equals 3 for this, slash iterations, 3, finally. A parameter to remove outlayers. 2.5. All these parameters are described in the Fusion documentation. In this case, we don't want to export the DTM file because it will be generated by a mesh size of 5 meters per pixel, while we are interested in getting a DTM file at a resolution of 1 meter/pixel. Once set the parameters, we can see that the result will be dumped in this directory. This procedure will have to be repeated for the date of 2015. Therefore, we can replace the file 2015 we see that it dates 2015. Date 2015, and we change the exit name to have the suffix ground, loss. With the same processing parameters, and the result will be dumped in this directory. To generate the image or rasterize these point clouds, let's use the GridSurface Create Fusion algorithm that we can also be found in the interface of Fusion toolbox. This tool asks us for a cloud of points. We are required the mesh size in which we will work. In this case, we need 1 meter of resolution. The units must be indicated. We will set the output file. In this case, we can perfectly take the same input name and change only the output extension that has to be asterisk. DTM is the own format of Fusion. To be able to visualize quickly the generated file, we can go to the Fusion directory, open the PDQ tool, and drag the DTM file in. We can see that the filtering hasn't removed all the vegetation or all the buildings. However, the parameters chosen are optimal to eliminate the shallow vegetation of the dunes. Preserve the dune beach transition and maintain the beach space. Therefore, the parameters will have to be adapted to each specific purpose. Then, just to follow and structure, we'll convert. The second point cloud of 2015 with the same parameters and resolution to DTM format. Once the two models are available, we know that these files with asterisk DTM extension are images or raster which should be converted to TIFF in order to work in QGIS. For this, it is suggested to make the transformation DTM to NV, although we will indicate extension TIFF-C. We can take the file DTM, and we'll just convert to TIFF. The DTM2NV tool generates a file which preserves the height value of each of the pixels of the DTM. If we use DTM2TIFF, they would be rescaled to values between 0 and 255. We can indicate that the file is opened directly once processed. Once the conversion has been accomplished, we can visualize the result in QGIS. To clarify the visualization, what we can do is to transform it to Graymanaband and give it a change in the range of values. For example, between 0 and 10 meters of altitude. So you can see the result of the DTM obtained for 2009. And also for the date 2015 between 0 and 10 meters. Once we get these two models, the goal is to calculate the difference of what has happened between these two dates 2009 and 2015. For this, the simplest option is to open the raster calculator and calculate the difference between 2015 and 2009. We can save the result, for example. In Changes, TIFF. This model contains the differences between the two dates. A way to visualize it clearly is to use a correct color ramp, for example, pseudocolor monoband. We will use the spectral color ramp, which allows us to analyze in red the negative changes and in blue the positives. These exaggerated values of 200 or plus fortim are due to outliers or areas where the two models do not match. Therefore, we can limit changes between 2 and plus 2. In this way, we can see the map of changes. The sea area doesn't make much sense because it is the state of the sea at each acquisition time. In this area on the left, it doesn't make much sense either, given that we have adapted the filtering parameters to the space of the beaches, and that's where we can do an analysis of changes. Observing that between 2009 and 2015 in this section, there has been a gain of sand. But in red values you can see the volume loss, that it's the general behavior all over the beach space. Particularly striking is the dune space that was lost between both dates in this area. Here. To better understand what has happened in this space, we can load the orthophotos 2010 and 2015. Despite the fact that the date does not coincide completely, from 2009 and 2010, there were no significant changes. So, if this is the 2010 date and we withdraw it to observe 2015, we see significant changes in the vegetation and dunes, which is the space detected by the DTM changes. Therefore, so ends the fourth method video. Three-dimensional characterization for beaches and dunes, where we have seen how to generate digital models of the terrain from point clouds and how to make a difference between them. For a visual characterization of space,